Our third best practice emphasizes embracing asynchronous communication between microservices. While synchronous RESTful API calls are straightforward, they introduce tight coupling and reduce overall system resilience. When Service A directly calls Service B, Service A must wait for Service B to respond, and if Service B is unavailable, Service A fails. Asynchronous communication, typically facilitated by message queues or event buses like Kafka or RabbitMQ, decouples services. Services publish events or messages to a broker, and other interested services subscribe to these events. This means Service A doesn't need to know about Service B. It just publishes an event, allowing Service B to process it when it's ready. This pattern significantly enhances fault tolerance, scalability, and responsiveness. For example, an order-placed event can trigger multiple downstream services like inventory update, payment processing, and shipping notification concurrently and independently without any direct dependencies, making the system more robust. Our fourth best practice is to implement an API gateway. As the number of microservices grows, clients face the challenge of interacting with many different endpoints. An API gateway acts as a single, centralized entry point for all client requests, abstracting away the underlying microservice architecture. Instead of clients needing to know the specific addresses of user service, product service, or order service, they simply send requests to the gateway. The API gateway is responsible for several critical functions: intelligent request routing to the correct microservice, authentication and authorization, rate limiting to prevent abuse, caching common responses, and response composition, where it aggregates data from multiple microservices before sending a single response back to the client. This simplifies client-side development, improves security, and enhances system performance and maintainability by offloading common cross-cutting concerns from individual services. It's an indispensable component for managing external interactions in a microservices ecosystem. Next, we have best practice number 5, prioritize observability. In a distributed microservices environment, understanding what's happening within your system is paramount. Observability goes beyond basic monitoring. It's the ability to infer the internal state of a system by examining its external outputs. This involves 3 pillars: comprehensive logging, real-time monitoring, and distributed tracing.